Hi guys, this is lesson 3 in unit 7. We're going to talk about factoring a trinomial with a leading coefficient other than 1. We learned how to multiply polynomials at the beginning of the year, and we said that we use double distribution to be able to multiply a binomial by another binomial. In this example, we have 2x plus 3 times x plus 11. By using the double distribution, we'll be able to change the factored form into the standard form by multiplying 2x times x to get 2x squared, 3 by x to get 3x, using the distributive property again to multiply 2x by 11 to get 22x, and 3 by 11 to get 33. If we look at this polynomial, it's not completely simplified because we have two like terms, 3x and 22x. When we combine these two like terms together, what we get is 25x. So the final trinomial for this factored form is 2x squared plus 25x plus 33. And as you can notice, the first number in the trinomial is basically the multiplication of the first numbers in the factored form, 2 and 1. 2 times 1 is 2. So the first number in the trinomial is basically the product of the first two numbers in the binomials. The last number in the trinomial, which is 33, is basically the product of the last numbers in the binomials. 3 times 11 is 33. So the final number in the trinomial is the product of the final numbers in the binomials, and the first number in the trinomial is the product of the first numbers in the binomials. Now, we said that the middle number is always the sum, but in this case, we have to pay attention to the sum, because it's not basically the sum of 311 anymore. This is a trinomial with a leading coefficient other than 1. That means that we don't have 1 as the leading coefficient in this trinomial. That means the number in the middle of the trinomial is basically the sum of the product of the inner terms. 3 times 1 is 3, and the product of the outer terms. 3 times 11 is 22. And now 3 times 22, or 3 plus 22, since we're talking about the sum, 3 plus 22 is going to be 25. And that's where the middle number come from in the trinomial. So basically, this is what we know. 33 is the product of 3 and 11, which is the final number in the trinomial, the product of the final numbers in the binomials. 22 is the sum of the product of the inner numbers, 3 times 1, and the product of the outer numbers, 2 and 11. And then 2, or the first number in the trinomial, is basically the product of the first numbers in the binomials. Now let's look at this trinomial. We have 3x squared minus 2x minus 8. and we're trying to change that trinomial into the factored form by using factoring. So looking at this trinomial, I know that I'm not going to be able to use the greatest common factor to factor this trinomial. This is not the difference of perfect squares, so I'm not going to be able to use conjugate pairs to factor this trinomial. So the only choice that I have here that can help me factor this trinomial is guess and check. I have to guess the factors and check for correction. So I need to use whatever we found out in the previous example to be able to factor this trinomial. I know that the first number in the trinomial is the product of the first numbers in the binomials. The last number in the trinomial is the product of the last numbers in the binomials. And the middle number here is the sum of the products of the inner terms and the outer terms. So let's use this information to be able to factor. So I have to think, let's work with the first number, the first numbers. So I have to think of two factors. If I multiply, I get 3 to use in my binomials. I know that 3 times 1 is 3, which means that my choices for the first terms can be 3x and x. I know that the last numbers, the product of the last numbers should be -8. So I'm gonna use -4 and 2, because -4 times 2 is going to give me -8, or 4 and -2, 4 and -2, because 4 times -2 is going to give me -8. I also can use 8 times -1, or -8 and -1. So as you can see, guys, it's a lot of guessing and checking. So be smart about your choice. Let's work with -4 and 2 first. So if I put -4 and 2 in my factors here, 3x minus 4 and x plus 2, my inner, or the product of the inner terms, is going to be -4 times x, which is -4x. And the product of the outer terms here is going to be 6x. So looking at the sum of these two products, I'm going to have -4x plus 6x, which is 2x. And this is not what I want. So I still can work with these two numbers, but by switching their place. So I can check if these two factors can give me the right trinomial if I multiply, or if I put 2 in the first binomial and -4 in the second binomial. So multiplying the inner terms will give me 2 times x, which is 2x. Multiplying the outer terms, I'm going to have 3 times -4, which is -12. Now, the number in the middle is supposed to be the sum of these two products. 2 plus -12 is -10, which does not give me -2. So these or this combination of factors is not going to work for me here. Let's try 4 and negative 2 now. So again, I'm going to put 4 in the first binomial and negative 2 in the second binomial, and check for the middle sum. So we have 4 times x is 4x, 3x times negative 2 is negative 6x. If we add these two products together, 4x plus negative 6x, I'm going to get negative 2x, which is exactly what I need for this trinomial. So this combination of factors, it will work, and I have to keep the place for each number. So 4 is going to be with 3x, and negative 2 is going to be with x. If I switch them around, I'm not going to end up with the same trinomial. So let's take a look. If you switch 3x minus 2 instead of plus 4, and x plus 4, to see if it's going to give us the same trinomial. The inner product is negative 2 times x, which is negative 2x. The outer product is 3x times 4, which is 12x. Negative 2x plus 12x is 10x, which is not negative 2x. So to be able to factor this trinomial correctly, we have to keep the factors in the right binomial. That means that the factored form for this trinomial is 3x plus 4 times x minus 2. It's a lot of work to be able to use guess and check when we have a trinomial with a leading coefficient other than 1, but that's the only way that can give you the most accurate factors. Now let's take a look at this trinomial. We have 5x squared minus 9x plus 4, and we're trying to factor this trinomial. Looking at this trinomial, I don't have a greatest common factor between these terms in the trinomial to be able to use GCF to factor. This is not the difference of perfect squares, so I'm not going to be able to use conjugate pairs to factor this trinomial. So my only method that I can use right now is guess and check to be able to factor this trinomial. And since we have a leading coefficient other than 1, the leading coefficient here is 5, it's going to be a lot of guessing and a lot of checking to be able to get to the right binomials. So let's start. I know that the first number in the trinomial is the product of the numbers in both binomials. And since I have 5 as the product, I know that my only choice of factors that I can use here is 5 and 1. So I'm going to have 5x in one binomial, and I'm going to have x in the other one. I know that the last number in the trinomial is the product of the numbers inside the binomials. So, and thinking about the factors that I can use, I know these two factors need to have the same sign for me to be able to have 4 at the end. So my choices can be 2 and 2, because 2 times 2 is a 4. It can be negative 2 and negative 2, because negative 2 times negative 2 is 4. It can be 4 and 1, because 4 times 1 is 4, or it can be negative 4, negative 1, because negative 4 times negative 1 is 4. So I'm going to work with each one of these factors to be able to find which one will give me this trinomial. So working with 2 and 2, if I put 2 in one factor and 2 in the other factor and check for the middle number in the trinomial, I'm going to have 2 times x, which is 2x, as the product of the inner numbers, and 5x times 2, which is 10x, as the product of the outer numbers. If I add these two products, I'm going to end up with 2 plus 10, which is 12x, and this is not what I have here. I don't have 12x, I have negative 9x. So this combination is not going to work, and it's not going to help me switching these two numbers because they're the same. Let's take a look at negative 2 on negative 2. I have 5x minus 2 in one factor, and then I have x minus 2 in the other factor. So multiplying the inner terms, I'm going to have 2 times x, which is negative 2 times x, which is negative 2x. And multiplying the outer terms, I'm going to have 5x times negative 2, which is negative 10x. Negative 2x plus negative 10x is negative 12x, which is not going to help me in this case. Now 4 and 1, I have 5x plus 4 and 5x plus 1. So multiplying the inner product, I'm going to have 5 times, this is supposed to be x, so 4 times x is supposed to be 4x, and 5x times 1 is 5x. 4x plus 5x is not negative 9x, it's 9x. So to get to negative 9, I have to make a smart choice. Should I continue and switch these two numbers and check for the sum, or should I do something with these two numbers to be able to get negative 9x at the end? So I think I'm gonna make a smart choice, and instead of just switching these numbers, I'm gonna try and work with 5x minus 4 actually, let me just put it down here. 5x minus 4 times x minus 1. So if I look at the product of the inner terms, I'm going to get negative 4 times x, which is negative 4x. 5x times negative 1 is going to give me negative 5x. If I add these two products, I'm going to end up with negative 4x plus negative 5x, which is negative 9x, and this is exactly what I need. So I'm going to eliminate these two choices, and I'm going to keep this combination of factors in this order to be able to get the right factors. I'm going to put negative 4 in here and negative 1 in here. So the factored form for 5x squared minus 9x plus 4 is 5x minus 4 times x minus 1.